All right, today we're looking at writing systems of equations from verbal descriptions, and this is one of the more fun things that we do because you get to look at um, taking some less straightforward information and putting it together to actually solve for the thing that you didn't know. So it's almost like working out a riddle, just using linear equations to figure it out. So many real world situations require you having more than one variable or unknown. And so if you understand what the problem's asking and you can define the variables, so you're able to clearly define the variables and writing two equations. And so some of this is kind of intuitive, that the simpler ones of these we're able to kind of solve in our head, but the more complex they get, the better it is to know like kind of how to work the formula out. So let's look at the first one. Marcy has a younger sister, Darcy. And so my thing that I'm going to do there is I'm going to put a O there for older and a Y there for younger, just so I remember Marcy's older, Darcy's younger. The sum of their ages is 42. Marcy is 4 years older than Darcy. Write a system of equations to determine their ages, the ages of Marcy and Darcy. So you could do this with your age and anyone else's age, and it's a way of saying this many years older than this person or younger than this person, and the sum of our ages is this. Then you can figure out, hey, how old are you actually, or how old is that person actually? So what I'm going to do for this is, let's see, we'll just say M equals Marcy's age. And D equals Darcy's age. And so it says the sum of their ages. So Marcy plus Darcy equals 42. And Marcy is 4 years older than Darcy. So if she's 4 years older, this is the part we can get messed up. You could either say, if I take Marcy's age and subtract 4, I'd get Darcy's age. Or I could say Darcy's age plus 4 equals Marcy's. Either way works. So we're not really looking at solving them right now. One of the easier ways to do it is to change, instead of M, put X, instead of D, put Y. Be able to graph it and solve it from there. The other way we could do it is to plug in the M minus 4 for Darcy and solve it that way. Would be substitution. Or we could eliminate one that I'll show you just quickly so we know how to solve them, or have an idea at least. If Darcy's age is whatever Marcy's is minus 4, well, where that D is, I'm just going to replace that with this equation. So Marcy plus Darcy minus 4 equals 42. And so if I do M plus M, it's 2M minus 4 equals 42. So I'm going to add 4 to both sides. So 46 equals 2M. Divide by 2. And Marcy's age would be 23. And then I just do 23 plus what is 42. So if I do 42 minus 23, that would be 19. And we get the ages. Those are the only two ages that are 4 years apart that would add up to 42. Okay, and so that gives you the full example of solving it, but we'll look at just writing the equations from here on out. So Edgar has $24.55 in quarters and dimes. So if I just say Q is quarter and D is dimes, then looking at, he's got that much money and he's got 17 fewer dimes than quarters. So I should have fewer dimes. So I would say, when we're looking at the number of quarters versus the number of dimes, if I say Q minus D, so quarters minus dimes, equals 17. Or really, I guess the better way of writing that you'd probably see it a little easier, is quarters minus 17 equals the number of dimes. Write it that way. Then when I'm looking at the value, well, we've got to know how much dimes are worth and how much quarters are worth. So quarters worth 25 cents. So almost any time that you've got money like this, you've got 25 cents in quarters, like 25 cents per quarter. A dime is 10 cents, so 0.1. And if I total that up, it gives me 24.55. And so once I've got that written, and that's a decimal number there, if I can change it to my slope-intercept form or do the substitution like I did earlier, there are a lot of things you could do. You can figure out exactly how many dimes and quarters there are. You've also got guess and check. There's only a limited number that I could do that would be that minus 17 to get that. So you've got a couple of options when you're solving there. And again, we're looking at just writing it out. So next one, at a farmer's market, you got strawberries cost this much, blueberries cost that much, so $3.85 and $4.90. Strawberries, blueberries we'll say is B. Twice as many pints of strawberries as blueberries. And so we double the amount of blueberries, we should get strawberries. Well, sometimes the way they say it ends up kind of the opposite. So if we got, it helps sometimes to put numbers in here just in your head real quick. So Mary bought twice as many pints of strawberries as pints of blueberries. So if she bought 5 pints of blueberries, bought 10 pints of strawberries, that reflects that relationship there. And then she spent a total of $25.20. So whatever the strawberries cost, so $3.85 times S plus $4.90 times B equals that total, $25.20. Okay, and that gives us information we could use to solve that out. We could substitute, I'd probably just put in 2B for the S there, multiply that out and add it together, solve for the number of blueberries, and then figure out the rest from there. Okay, looking again at money, paid $10.10 for 8 apples and 6 pears. So 8 apples plus 6 pears equals $10.10. So $10.10 there. Drew paid for 10 apples and a dozen pears, and that cost $16.90. And so these to me, and it says use X and Y. I used A and P. That if we did that with X and Y, it'd just be an X. That'd be a Y, X and Y. Okay, same thing is still going on there. Again, we're just writing the equations. And these are still, the thing with these, when we put them in the y-intercept, it ends up looking like some weird numbers, but really that gives you a quick way to solve it if we can put it in slope-intercept form. Now let's look at one more of these two on the bottom. Let's see, we'll do the football game. So 500 people attend a football game. Student tickets cost $3. Adult tickets are $4.50. Ticket sales are $1,770. We want to find the number of students and the number of adults attending the football game. So the first thing, and kind of skip right over, is that it says 500 people attended the football game. So that's between adults and students. Those are the only options we're given. So adults plus students equals 500. Then it's finding out from the total. We're doing same as like the quarters and dimes, that a student, when we're thinking about cost, every student ticket's $3. An adult is $4.50, so 4.5A plus 3 times S equals 1,770. And so if we were to put that into, slope-intercept form, instead of A and S, we'd use X and Y. But all I would do is, let's say, I'll subtract A from both sides to get S equals 500 minus A. Subtract 4.5A from both sides of this one. And then I have to divide by 3. And so all I would do from there is just change this to X and Y. So it would say Y equals, make sure we've got the same letter on the side over here. So Y equals 500 minus X, and Y equals 770 divided by 3 minus 4.5X divided by 3. And we can write it just like that. And when we put it in to the calculator, it'll give us an answer. So again, this is just learning how to write the equations for it when you've got those problems. But I'm going to challenge you, when you've got the time, to try out solving a couple of them just to see how it goes.